My name is Landry Kulawong. I'm in product marketing at OSIsoft. Been around here 6.5 years-ish. Started in support, and now I'm in product marketing.
Hey everybody, my name's Tom. I'm a systems engineer at OSIsoft, working out of our San Leandro office. I've been with the company about 3.5 years, and my job is to help customers like yourself, find out how we can use a Pi system to solve your problems.
So in case you've been here the whole time in this track, just to give you a landscape here, we're in the third talk, focusing on process optimization and advanced analytics and how Pi, the system, can enable that. And we recognize that process optimization is not kind of like you do one project and you're done, right? It's a journey. You might start to enter into that where you have actually a thing that needs to be solved for the business right away, kind of fighting fire type scenario. Then you might move on to a point where you might have to prioritize something else, or you might want to chase this opportunity around process optimization. So we're going to talk to this a little bit through customer examples, but just want to recognize that this is a journey. And what will we be addressing? So how can the process of process optimization actually be optimized, right? And then the other question we're looking to address is amongst the buzzwords of data science and advanced analytics, is there anything that can help me optimize my process? And within that optimization of a process, there questions are probably not new, right? Things you've seen before: increased production, decreased production time, et cetera. So they're probably similar, but if we think about the process, you guys might use this, right? Identify something that's inefficient in that system, analyze it, what is actually causing the inefficiency. You use your expertise to figure out how can it be improved, what changes can it make to the system to affect it, and then go back and validate it. So that's not new, but what might be overlooked is some gotchas along the way, some friction that could make this process take longer than needed. So data could resolve in different databases with different protocols that you have to pull out and put in maybe a spreadsheet that only you have that version and nobody else does, and you might be arguing over what version is the truth and did someone do the right calculation or not. So there could be some overhead to actually beginning the process, right? The other challenges are more around in the implementation phase of actually the part that you're most interested in, looking at thermodynamics or fluid mechanics or things like that to analyze the system. So how can Pi help with this? I'm going to pass to Tom. He's going to talk about a customer story that highlights this.
So the question is how can we use the Pi system to help us optimize a process, right? So I think a great way to do this is to show you guys the story of one of our customers, Deschutes Brewery. So you guys remember them from the keynote, right? So they talked about a really cool predictive story, but we're going to start off with something that they did pretty early on in their journey, right? So just a quick recap: Deschutes Brewery, they're the 7th largest U.S. craft brewer, and they've been a Pi customer since 2015. So before we started talking about all the advanced analytics stuff, they had a problem within their process pretty early on. So when you're fermenting beer, when you're making beer, during the fermentation process, there's a part of the procedure where you need to cool the batch, right? Cool a batch of beer. So they had these new vessels, and they were seeing some uncharacteristic cooling behavior with those vessels. And they were able to use a Pi system to quickly and efficiently implement a solution to correct this behavior. So we're going to talk about what that problem was, how the Pi system helped them to solve it, and what are the business impacts of this solution. So really quickly, the diagram on the left you see, there, it's sort of a graphical representation of what a fermentation vessel looks like. right? And the little TICs that you see sticking out of it, those are the temperature sensors on the top, middle, and bottom portions of the vessel. So those help track the temperatures in those zones during the cooling process. So in the middle of the screen, this is the core site display that is tracking the cooling process at Deschutes. So essentially, what we're seeing is the top, middle, and bottom zone temperatures, they eventually converge to a set point, and which completes the cooling process. And in this case, in particular, we see a ideal cooling process. So this is what a cooling process should look like if everything goes right? This is sort of what we want to see. However, this is the problem that we're faced with here. There's some uncharacteristic behavior, and essentially what happens is, as the cooling begins to start, you can see immediately that the top zone temperature begins to separate. So what that means is, as the batch cools, the top zone is actually at a higher temperature than the rest of the vessel, which is a problem. And during this process, Deschutes actually disturb the contents of the vessel when they remove some yeast, right? So when they remove this yeast, they see this huge spike in the top zone temperature. And this is the problem for Deschutes for two reasons, right? One, because of this spike, you can see that it takes longer for that batch to actually reach its set point. So number one, that's going to lower their production capacity because it's going to take longer for that batch to sit in that vessel to complete this process. In addition, the longer that the batch sits in the vessel, the more effect that has on the taste of the beer. So quality is also a big concern. And if you guys have had Deschutes beer before, you know that's something that they highly value. So before we move on to solving this problem, let's just take a look at what has already happened with the Pi system, right? So even at this stage, before we solve the problem, the Pi system has already helped Deschutes in some ways. Number one, data archive, right? So instead of looking for those sensor data from different data sources and different data silos, we consolidated all that sensor data into the Pi data archive, and we can retrieve them from the same location. Number two, we have the Pi asset framework, right? So we can, with these raw data streams, we can contextualize and label these data streams and organize them into assets. In this particular example, we've organized all these sensors into particular fermenters, right? And with those assets, we can use them and start to build a model, right, of the whole process, of the whole plant. And of course, with event frames, right? So these cooling processes, they have very definitive start and end time. So, right? So instead of looking at a trend and stepping back and trying to find those cooling processes in that continuous data stream, we can actually capture each cooling process in its own event frame. So that when you're back in Pi core site and you're trying to visualize these event frames, you can simply browse by the event, right? And the more powerful feature on top of that is when you start to work on this problem, it's very easy to compare events. Before you made some change, after you made some change, and you can compare those values on the same time axis. All right, so back to the problem, right? So Deschutes, they solved this problem and they tried many different things. Along the troubleshooting process, they realized something that was interesting, right? So when the vessel is at the point where it hasn't really reached that bottom sensor, they realized that they were lacking visibility into what was going on into the tank, right? In the cone of the tank, which is right there. So they decided to actually add an additional temperature sensor to the cone of the tank to give them that visibility. So with that new sensor, essentially we have a new data point, right, within Pi. So it was very easy for us to bring that data point into Pi and repeat a cooling process and see how that impacted or what the results are in our visualization. So let's see what happened, right? So with what you're looking at here is a Pi core site trend of a cooling process after they've added that new temperature sensor. So right off the bat, we still see that huge top temperature spike as you see in the orange trend, but in the blue trend, that's the cone temperature. And for the engineers at Deschutes, right away they saw a correlation between these two things, right? So as the cone temperature decreases, we actually see that top zone temperature start to spike up. So with this information, they thought, hey, maybe there's some relationship there, right? So essentially, with this information, they formed a hypothesis, and their hypothesis was that, okay, something that's going on at the bottom of the tank, that this warm mass migrates to the top of the tank, and that's what's causing that behavior with the top zone. So based on this hypothesis, they decided to implement a change. So instead of doing what they did before, how about let's start to cool the cone of the vessel before we start cooling other parts of the vessel, right? So when the fermentation starts, that cone temperature is already cooling. So with that change, let's see how what happened, right? So after we've implemented that change, immediately we can see that this looks a lot better than before, right? So we still have a little bit of that top zone spike, but for Deschutes, this was an acceptable deviation, and you can see already that because it's taking a lot shorter time for us to complete this process, we've essentially increased our production capacity and maintained a good quality in our beer. So a quick recap, right? The 4 steps that Landry talked about. How did the Pi system help in each of these steps? So even when we're looking at the data initially, right, with Pi CoreSight, we're able to easily overcome the data silos, right? All your data is in one place. You were able to use Pi CoreSight to quickly develop those visualization, right? You have a single version of the truth, so that nobody's arguing about, okay, no, this analysis is better than this one, right? You have a single set of that, and also, when you're comparing event frames, comparing different cooling events, with event frames, you're able to easily make that comparison right in Pi CoreSight. And of course, after we've after we've implemented the solution, we're able to go back into Pi CoreSight and validate that our solution actually improved our process. So with that, I'll hand it over back to Landry, who's going to talk a little bit more about advanced analytics.
All right, thanks, Tom. So Deschutes was able to use the Pi system to solve that process inefficiency by quickly getting out the data, zooming in on that event frame, right, and implementing a change in the process. So now they want to look at, well, if we take that Pi system data and put it in advanced analytics platforms, like what could be achieved, right? And advanced analytics here, I'm not going to claim the Webster definition, but kind of the general ideas underlying that, I would say, is bringing your operations process data from Pi into something like a data warehouse or a data lake where you can mix it with other business data, and you get this holistic view on a data set. Another piece is bringing that into BI tools like Power BI and slicing and dicing the data, looking for that visual correlation that's maybe hard to find across many dimensions. And then, of course, using machine learning or data science experiments to find predictions of your data or looking for prescriptions around it. So we'll focus on this one, and we're going to stick on the same customer. You heard about the business case earlier this morning, but we'll go dive into a little bit of the nuts and bolts of it. And so just as a reminder, they focused in on a particular step in their process, and Deschutes was looking to say, if I can just make 2 or 3 measurements of density, could I predict transition? So before they did that, and they alluded to this in the talk this morning, but before they did the full-out advanced analytics project, they brought in the data into a spreadsheet for a couple brands and vessels, plotted it. You can see there in the middle. Said, OK, well, that kind of looks like a line. I think I could fit something to that. And they fit a linear regression to that. And you can see it's pretty good in terms of predictability. So they gain confidence that, OK, well, we could probably do this for most brands and hopefully for other vessels as well. So they said, OK, well, we have the Pi system having this density measurement in there. And then we also have this suite that we know about, the Cortana Intelligence Suite, that has the ability to do that data warehousing I was talking about, as well as the machine learning capabilities So how can we kind of automate this piece? If I forgot to mention, but doing this for every brand, every vessel, they had 50 plus vessels, I think 11 something brands, and then doing this process for each measurement, right? As they get a measurement in, they'd have to do this as well. It's just time consuming, so they wanted to figure out how to remove that and automate it. Oops. Sorry. Tom's going to show you how the Pi integrator for Microsoft Azure helps automate that process with a self-service UI.
I don't think they have the latest slides. Yeah, so unfortunately, we don't have the video demo available, but let me verbally describe what that looks like. So Landry posed the scenario, right? We need to essentially somehow get our Pi data into the realm of Cortana Intelligence and Microsoft Azure, right? So with Pi data, you guys are familiar with tags and attributes, right? So within each Pi tag, you have a stream of data, right? And all your Pi tags, some might be 5-second data, some might be 1-second data, right? Now, when you're doing machine learning and a lot of this big data analytics, you expect that data to be in a tabular format, right? For a lot of these tools, that's how that data needs to be consumed, right? So we're talking about different columns representing the tags, and you have the rows maybe representing the different timestamps, right? So think about that, right? We need to convert that time series Pi data into this tabular format, and when you have this 5-second data, 10-second data, how does that match up, right? And if you're trying to put them all into a table. So essentially what the Pi integrator does is first, it augments your Pi data nicely into that tabular format. Second, as some of you guys might know, our Pi system is not perfect, right? We have, especially your data, sometimes you have spikes, bad values, right, in your data. And when you're visualizing them in, let's say, CoreSight, and you see a giant spike, it might not be the end of the world. You're like, okay, yeah, something's wrong with that sensor. But when that spike gets translated into that tabular format, all of a sudden it's not that apparent, right? You don't just glance over the table and see a big jump in the value. It's just a cell in that table. So filtering that data, cleaning that data is really important, and the Pi integrator actually allows you to do that. For example, if you want to output a particular value that's critical for your analysis, you want to make sure that that value has, or that tag has good values for all those rows in that table, right? So that's one feature of the integrator. In addition, once we have that table ready, we need a way to push that into the Azure world, right? And for a lot of these predictive analytics, we don't want to just do that once, right? As we get new data into a Pi system, because we're dealing with real data, we want our predictions to update, right, with that real data. So the integrator can let you schedule those your publications so that you're continuously or sending data to Azure, a data store within Azure on a periodic basis, so that when you are looking at your predictions, that they're always up to date with the latest information that you've received. Right.
Next time. All right, so let's see if I can get that. So a couple things to add to what Tom said. Self-service UI, so you basically shape the data with the integrator through a web browser. So you can use that. And then the other part, you might have heard Ray Hall talk about streaming for the integrator coming out this year. Right now, what's released is a batching capability for the integrator. So that enables you to batch over some data into things like Cortana Intelligence, train your predictive model, right? And you can schedule updates of that batch so that you can help retune the model as time moves forward and you gain more data. And then the streaming piece will actually, in the future, be able to give you that most recent event, pass it through your predictive model, and get the most recent prediction. Another thing I want to highlight about the journey with the shoots was that it was an iterative process, right? It's not like we just ship the data over and out pops a predictive model that's accurate. So if we work left to right, that blue line is just a way to benchmark our accuracy for the manual data, apparent degree of fermentation. And then if we just use pure mathematics, don't use any kind of domain expertise to define the data, you can see the first 2 points, the curve in the red, pretty bad. But as soon as we add in brand into the model, we get much better. So treat these types of projects in an iterative way when you go about them. And this is just to show that, you saw these this morning, but they were able to get accurate predictions that were used across all brands that they have out today, all vessels. And it also retuned itself as it gathers more data so that the model can become more accurate. So, in summary, we showed that we have the Pi integrator for Microsoft Azure that can link into the Cortana Intelligence Suite. So it preps that data, automates it, automates the preparation of it. You can set some rules to clean it, filter it, et cetera. Moves it in the right format for that training of the predictive models that you can generate in Cortana Intelligence. And in the future, we'll be able to stream to that as well. And then also, Tom talked about just getting the data into the hands of brewers at Deschutes. They were able to quickly solve a process optimization problem, focusing on one version of the truth and having the ability to just zoom in on data around events like the cooling phase or fermentation phase during the process. So thank you, and can take questions.
Yeah, sure. Do we need to wait for a mic, or? Oh, he's coming with a mic.
In your tank the geometry, the problem was that the cone was having a different kind of behavior, right?
Yes.
So I was wondering, why don't you just get rid of that cone and make it a perfect cylinder if cone geometry was the problem?
That's a great question, but unfortunately it's not one that I can answer.
That's one way to solve the problem, right?
Yeah, so unfortunately we're not brewers, so we can't answer that one.
So I know Tim and Brian from Deschutes, they're currently in the building somewhere, so please feel free to track them down and let them know your solution to the problem.
Anyone else?
Hey, all this talk of beer and no free samples, what's up?
Just holding you from the beer, right?
Yep.
I just have a question regarding the predictive analysis from the Cortana Microsoft. Is this different when you say predictive from the predictive data from the Cortana? Is this different from the future data that Pi is capable of doing?
They're used together, right? So when we get that predictive data out of Cortana Intelligence, right, Azure Machine Learning, in order to store them in Pi, obviously we're talking about data in the future, right? So they are stored as future tags in the Pi data archive.
This means that the tags have a timestamp that is already in the future.
Right.
Exactly.
But this is a separate tag from the raw tags.
Correct. Yeah, you would have a tag, something, ADF prediction, right? And then you have a tag that's ADF, which is your real-time value, right? Back there?
Yeah, when I was looking at your stuff, I'm assuming that you took the data and you exported it to the cloud, correct?
Correct, Azure.
And then you brought it back down to put it into Pi.
Right.
So what other tool did you use to make that happen besides just use the BI and send it up there, or did you?
Underneath the hood of Azure, or just to get it there and back?
Yeah, there and back.
So there is the integrator for Microsoft Azure. And then on the way back, we use Pi RDBMS interface.
Okay.
It's hard to see. No? I guess we're good.
One more?
Oh.
When you're using Azure, is that a continuous process, or is it just for a training process? Is it just an ongoing, just to get the future data that you continue to pump it up to Azure, or do you train it and then you're done?
So let's see. The patterns could be, one-off to train initially to get enough accuracy to feel confident in the model, right? So that goes live, and then you keep pumping live data into that to generate predictions.
Okay.
Right? And then after some time, you've gathered enough data in Pi to say, I think I can learn from this set, so I'm going to batch this over and then retune the algorithm based off of that.
Okay. Very good. Thank you.
All right. Well, thank you.